actually fully instrumented this heat shield and back shell. So we'll be collecting probably the most high-fidelity information we've had on entry systems to date. So we'll be able to tell exactly how much of the heat shield is ablated away as we enter. We'll understand what the pressures are and temperatures are. And since it's guided entry, the angle of attack changes, and so we'll understand how that applies across the front of this heat shield, not just a single temperature or a single pressure. And there's some back shell measurements as well that help us with pressure. These kinds of data sets are extremely important in constructing entry, descent, and landing profiles that will apply to building larger systems that are capable to send humans. I'll let Michael talk about an instrument that we have aboard that was also supplied by the Human Exploration Group.
Yeah, thanks, Doug. The instrument is RAD. It's a radiation detector, and it's a broad-range sensing instrument that is specifically designed to get a handle on what kind of damaging radiation would be at the surface of Mars. And the reason why you want an instrument like this is that although you have a good idea of what the radiation is in space, what happens to is that as the radiation goes through the atmosphere is that you generate what they call secondaries. So you can, in fact, generate other high-energy particles that are actually more damaging than the original radiation itself. So RAD, the radiation detector, will in fact give you a good idea of what species are generating, what the radiation environment at the surface of Mars. And with that knowledge, then you can go about figuring out how to protect astronauts when they go to the surface.
Our final question comes from Leo Antreich from Irish TV. Leo?
Thanks very much, Dwayne. As a TV man, I'm interested in the pictures, and I just wondered, I heard Pete talk about black and white in days 1 to 3. Is that worst case? Could we expect to see color pictures earlier? And more specifically, I'm being asked by editors all the time, what are we going to see? This mountain is bigger than the tallest mountain in Europe. Can you describe for us in more detail what television we can expect? What are these cameras going to produce? Is it going to be like the rover on the moon landings where Captain Video was able to move the camera around and look at things, or is it going to be more like the MSL, the Mars, the earlier Mars rovers?
Well, it'll be much like the earlier Mars rovers. The data is collected in pre-pan sequences, so we'll be doing panoramas, so you'll see basically that kind of panorama like you've seen from Spirit and Opportunity. They're very high-resolution cameras. They certainly are better than high definition, at least the science cameras are, with basically full and natural color this time. I think that the cameras, I'm not that conversant with the optics of them, but I think that they'll be very good. The frame rate for the descent imager is certainly capable of doing a movie, if you want to do a movie, an 8 frame per second movie. The black and white photographs will be very good resolution. I don't think you'll see them as low resolution, but they will be black and white. The first color image will be taken from the MOLLE, the camera that's on the arm that basically is designed to look at rocks in a very close high resolution setting. That camera does have excellent optics features at infinity, and it looks out the side of the arm. The one thing we can't control is the orientation that the rover lands in. So if that's your first color picture, and if it happens to be pointed at the mountain, we'll get a great picture at the mountain, and if it happens to be pointed the other way, we'll get a great picture at the rim, et cetera, et cetera.
Okay, we are going to wrap up here. And before I toss it to someone who really knows about countdown clocks, Dr. John Grunsfeld, to give us the latest on the count, I want to remind folks, come take this journey with us. Follow us on social media, Twitter, at Mars Curiosity, Facebook, YouTube, all the social media out there. It will be an incredible conversation, incredible products. Also, for more information, www.nasa.gov/Mars and www.nasa.gov/MSL. We've seen the education and public outreach products, but make no mistake, ladies and gentlemen, this is serious business. If there's one thing to take away from this, this is the hardest mission ever attempted in the history of planetary robotic exploration. It is real. Come go with us. The team is ready. And now, the latest on the countdown to John Grunsfeld.
So if you want to know how long until landing, go to worldwideweb.nasa.gov/Mars. 20 days, 11 hours, 25 minutes, and 41 seconds. Thank you very much.
Good job. Excellent. Yeah, very good.